2016, analysis services has been updated along with other business intelligence options. Most of the changes in analysis services for 2016 is with the tabular model. Covered are changes mainly in relationships, which is the bidirectional filtering. There's also some time intelligence and DAX functions that have been added. With the administration of SQL Server Analysis Services, we're going to look at performance improvement and the additional functionality like DBCC CheckDB for analysis services databases. There are many DAX additional options and functions that have been added, and we're going to cover the ones most likely to help when people develop analysis services databases or run reports against those databases. A big deal right now is the cloud, and with Microsoft's cloud-first development, analysis services has now been moved into Azure as a service. It's called Azure Analysis Services, and it's generally available now with SQL Server 2016. There's an option for direct query to on-premise database, which everybody is going to be excited about. The gateway is what is provided for this functionality. Now, all people still in analysis services usually have multidimensional cubes, and the cube development has not completely stopped, but it has slowed down. Just the basics have been added, like new connectivity to new data sources. There's also huge performance improvement for the distinct count measure group, which is usually a separate measure group than your normal measures like sum and count for a particular fact table. So what they have done is they've enhanced the T-SQL in the background that gets the data. Mainly the enhancements are for the Oracle and Teradata databases. With any development now in any Microsoft product, you're going to be looking at PowerShell commandlets. PowerShell is expanded in SQL Server Analysis Services 2016 with administrative functions and development enhancements. There's also the TMLS script language that is used instead of XMLA for cubes. But before you can use any of these new features, be sure to go get the latest SQL Server data tools from Visual Studio 2015. This must be downloaded and installed, and there are new capabilities in SSDT to deploy to different versions of BI tools like integration services, analysis services, and reporting services. SQL Server Analysis Services 2016 comes with something called bidirectional filtering. If you've used Power BI in the last couple months, you notice it was added here first before SQL Server Analysis Services 2016. Bidirectional filtering helps solve the many-to-many relationships and other counts and across table measures. No longer is it complicated to have to write the DAX measures needed to accomplish this task, although you do need to be careful in the design of the database as well as how many table relationships you use this bidirectional filtering. The built-in approach to tabular model makes cross-table filtering in the relationship rather than DAX using it in DAX code. Bidirectional cross filters can be an easy fix to that many-to-many query design problem that has challenged so many people. Bidirectional filtering enables a context filter on a table now directly related to another table through a secondary table. Some people call this secondary table a bridge table, and it usually doesn't have any measures. The context can be filtered in that second table. Cross-filtering is when a filter context on one table directly related to another is used. So bidirectional transfers the filter context to the second table. If you enable two-way filters everywhere, your data could be over-filtered in ways that you might not expect, hurting performance. You might also inadvertently introduce some ambiguity between the different query paths you're using. You want to avoid these issues, and you want to plan the combination of one and two-way filters very carefully. Do not enable all these relationships as bidirectional. Planning is based on your requirements. Remember, this enables filtering both ways, so a lot of resources could be used in filtering all direction. Testing is really important. You just don't enable and assume the results are going to be the way you plan. Internally, two-way filtering expands the filter context to a query of a superset of the data. Do incremental testing while developing to verify the impact of each filter change on your model. If you analyze it in Excel, that works well for incremental testing. As a best practice, you should periodically follow up the testing with other reporting clients so that there are no surprises later. Also, in the development in Tabular, there has been added display folders, which was available in multidimensional cubes. Only the 1200 and above compatibility tabular model supports this new display folders. If you're in a previous version, you can use BIDS helper to provide this in older versions. The neat thing about this is you're able to group either measures or dimension attributes together, so when they're displayed in the client reporting tool, it's a lot easier to follow along. SQL Server data tools defined and rendered apps like Excel and Power BI. Display folders is going to help you organize large number of measures and attributes in these folders. It adds a kind of visual hierarchy to easily navigate the field list. Another big deal is translations, and this is for languages. You can now store translated metadata, but you have to create it yourself. The metadata in the model includes fields for culture, translated captions, and translated descriptions. To add the translations while you're editing a model, go to the Model menu and you'll see a translation command in SQL Server Data Tools. After you do this, you have to export a text file with the metadata columns. Then someone has to edit these translations to provide the translated, say, English to Spanish version. It's not easy, but it is doable, so it makes it more of an enterprise solution today. There are some free tools available in the SQL Server community to assist in this translation and helps you with a starting point. First, we're going to do a search on SQL Server Data Tools for 2017. Here, we'll find a link to where we can download this new version of SQL Server Data Tools. The nice thing about downloading and installing this, it does install it for, if you see down here, 2015, and it does support previous versions of SQL Server analysis services as well as integrated services and reporting services. But we're going to do a demonstration of some of the new features in analysis services. First, we'll launch Microsoft's Visual Studio. This is the shell program for the SQL Server Data Tools. We're going to go to File, New, Project, and we're going to pick Analysis Services Tabular Project, and we're going to give it a name like LearnNowOnline SSAS. We're going to go ahead and let it create a folder for the solution. We have Analysis Services selected, but you also see the templates for integration services as well as reporting services. We'll stick with Analysis Services, a new tabular project, and click OK. We're going to be prompted for our workspace server. We'll talk later about integrated workspace, but I'm going to test my connection to make sure it's there. And if you notice, there's also a SQL Server 2017 Azure Analysis Services available option for compatibility. But we're going to stick with 2016 and click OK. Now this workspace database keeps the in-memory part of the design on disk in a database for later restores or retrieval. But what we're going to do is we're going to stick to a new solution. We're going to go to the Model menu choice and import from data source. We're going to stick with Microsoft SQL Server, pick our server that has the data. Once we have the server name, we'll drop down the list of databases and select the AdventureWorks Data Warehouse for 2016. We'll click Next, and the impersonation information A best practice is using service accounts for your analysis services deploys and retrieval of data. And we're going to select from a list of tables. Now, the big deal we want to demonstrate right now is bidirectional filtering and display folders. So I'm going to pick something like dim customer that has a lot of attributes, and dim date, because date is usually always used in a cube or tabular model. We'll get the product category and subcategory, and we'll also get sales territory. The big one for bidirectional is what's called dim sales reason. Now, dim sales reason is related to the fact table of internet sales reason. So this fact table is related to sales reason. The sales reason fact table is also related to fact internet sales. So this is what we're going to create that bidirectional filtering on, because we want to filter our sales reasons through the internet sales reason fact table to the internet sales. So that's the big one we're going to look at right now. We're going to give it some easier descriptive names, because we can do that here in the friendly name area. And we'll do that with all selected tables. You notice I'm putting a space between some of these, and that's okay with analysis services. And it makes it more readable for your end user. We'll do the same thing with product and subcategory. We'll actually take the product off, the dim date, and the dim customer. Now that we have that, I'm going to click finish, and it's going to actually import that data into our tabular model. Remember, the difference between tabular models and multidimensional cubes is that tabular is in memory and cubes are not. So you have to constantly deploy with cubes. But now we're going to get a display of what we just imported, and we could do some things to clean this area up. The main one I'm going to do is with internet sales reason. But before we do anything to clean it up, we're going to go to the bottom right where it has the diagram. And this shows the relationships between the tables that we're dealing with. I'm going to shrink it down a little because my fact table is this internet sales, and it is related to my date, to my sales territory, and down further is my customer. We also have product that's related to subcategory, which is related to category. And what you don't see on the right is any relationships to our sales reason. But if we scroll over, we can see those two tables. Here's our fact, and here's our dimension table. So what we want is we want the sales reason to filter through this fact table for internet sales reason, eventually to internet sales. I'm going to expand it down just a little bit just to show you the columns that we're dealing with. It's sales order and sales order line in these two tables. Problem is I can't multi-select these and drag and drop as a relationship. So I'm going to have to do a little trick. I'm going to go back to my grid view, and I'm going to go to internet sales reading, and I'm going to create a calculated column. I'm going to start with an equal sign, and I'm going to look for sales order number. I'm going to concatenate it with a dash, and then also grab the sales order line number. And if I hit enter, I should get a correct column. I'm going to rename my column to alternate key. Okay, so I have an alternate key, which is a combination of those two columns. I'm also going to go to internet sales and do the same thing. While I'm in here, I might as well go highlight some of these and go ahead and say hide from client, which helps clean up our display. I'm going to do it with a couple more. I'm going to leave, though, the total sales, which is our sales amount, total product cost for now, but hide some of these others. There's some tricks to all this, and you'll see some as we go along. But the main thing I want to do is that same calculation. I want to get the sales order number, concatenate it with the line number. See, the IntelliSense works really nice. You start typing, and it kind of knows what you're looking for. And that what you type is kind of partial of what the whole name is, which is really nice. So this is our alternate key. Now that we have the alternate keys, we'll go back to the diagram, and you'll see that alt key here and the alt key here. So I'm just going to drag and drop those, and now I have a relationship from sales reason to internet sales reason to internet sales. Before we look at it in Excel pivot table, I need to go create a measure. I'm just going to sum up the column total sales, and I'm also going to do total product. So I now have two measures down here, sum of sales amount, and I can actually now hide these from the client. Now there's a button in your toolbar called Analyze in Excel. It's an easy way to test your development, and I suggest using it very, very frequently. I'm going to bring Excel up to this window, and I've got a pivot table. Now if I click Sum of Sales Amount and I grab something like English category name, I see that I group by category, I get summed, and if I sum up those columns just to check my calculation, I should get a correct value here. So that matches to what the pivot table got. Now I'm going to copy this table, move it over a little, and I'm going to take my category name off, and I'm going to scroll down till I see sales reason. And if I grab that sales reason name and put it in my rows, I see the same amount throughout the whole area, and I might see some of these duplicated or some displayed that don't even have an amount there. So right now I'm not seeing the bidirectional filtering, but if I minimize this, go back to my development, to my diagram, and double click that relationship between those two tables, you notice in the filter direction we have something that says both tables. So I'm going to click that, click OK, go back to Excel and refresh this. Now you'll see that bidirectional filtering. What you also are going to see is if I try to do a sum of those rows, the value is greater than the grand total. So behind the scenes, this grand total is your grand total of total sales. But one particular internet sales could have multiple sales reasons. So that's why the sum of each row is greater than the total in the internet sales. And this is what people want with many-to-many relationships. One big thing that makes it easy in this case is that we just had one table to cross. When you have more than one, sometimes this tabular model does not work well. But don't give up, because any of these tables can be views. So if you have two tables out to the right, you can create a view to bring them together to put in this relationship diagram. And you saw how we were able to concatenate columns to become another primary key of those particular rows of data. Now let's go back to Excel, and you'll see lots of things to scroll to on the right? So your dates, your customers, your products, there's tons of columns. Well, that's what that display folders is. So if we go back to say the date, we could hide some of this stuff. Let's use product, because that's a nicer one. Or customer. We'll do customer, drag it down, and we'll see all kind of demographics. First of all, those keys we'll hide. Next, we'll say the title through the name style is at one particular display. This is our customer, right? And then some of the rest of these, like birth date through education, might be something like demographics. And then the remainder columns might be something like geography. So I just made those changes in my model. It saved them. And if I go back to Excel and refresh, now you'll see in the customer dimension folders that display those attributes. So this is a big deal because it was only available in BIDS Helper. But now with SQL Server Analysis 2016 and the latest SQL Server data tools, you're now able to do bidirectional filtering as well as display folders for your attributes, and even can do it with your measures. According to Microsoft, SQL Server Analysis Services has performance improvement when you develop. The first one they talk about is heap fragmentation. The Intel TBB-based scalar allocator helps to mitigate performance problems due to some heap fragmentations that occur in the Windows heap. Performance and scalability testing has shown significant gains with this new heap fragmentation. The query throughput in running SQL Server 2016 SP1 analysis services on large multi-node enterprise services is getting better and better. This was a big deal because multidimensional seemed to perform a lot better than tabular. The other is with memory allocation, and it has been accelerated in Analysis Services 2016 with Intel threading building blocks. That's the TBB mentioned earlier, the scalar allocator that provides separate memory pools for every core. And this has been around for a long time with these multi-CPU cores and sockets. So as the number of cores increases, the system can now scale linearly. And this brings us to the NUMA awareness, the non-uniform memory access. It is now enabled in 1200 compatibility tabular models for processing. This optimized memory allocation based on the Intel TBB is specific for those Intel processors. So it's mainly for the newer servers that are created. Now more users can be supported on bigger servers because of this NUMA awareness and shared memory on less cores. With this NUMA support, the in-memory analysis services tabular model maintains separate job queues because of NUMA. This guarantees the scan jobs run on one node, so the memory assigned to it is not on separate nodes. These machines at least have to have 4 NUMA nodes, but on a 2-node, the cost of accelerating the remote allocated memory doesn't really warrant the overhead for managing separate NUMAs. Which brings us to calculated tables. This is a DAX expression that can return a table. So the underlying data changes, so does the entire table formulated with the DAX expression. This is an automatic evaluation of dependencies when data is changed and is very similar to computed columns with SQL Server instances. The model-only construction based on a DAX expression or a query in SQL Server data tools is then deployed in the database. The calculated table is displayed no differently than a regular table and can be used the same way. There are several uses for calculated table, but the big one is when you want to expose an existing table to a specific role. This is a classic example with date tables where there's different dates, like in the Internet Sales Fact has order date, ship date, and due date, and you need some calculated table to relate to these multiple contexts and dates of fact tables. By creating the calculated table for a given role, you can activate the table in a relationship because of the role, and it helps facilitate the queries and data interactions that the calculated table is related to. Another use is to combine parts of existing tables, like a view, into an entirely new table, just like we were mentioning in the many-to-many. The last thing for development is the formula fix-up. Everybody's excited about this. With this new tool or ability in tabular 1200 models or greater, SQL Server data tools will now automatically update the measures that is referencing a column or table that gets renamed. This was a big problem and created many headaches. But the problem in these previous versions that frustrated so many developers is now fixed in SQL Server 2016. The final changes in tabular development deals with direct query. Direct query performance has been improved. The T-SQL has been enhanced along with the new DAX functions. And really, most of the improvements is because of the new DAX functions. Because this is an in-memory technology, tabular objects or tables perform better than T-SQL and SQL Server tables. That's why more DAX functions were added. Even in-memory tables in SQL Server 2016 is still slower with T-SQL than the in-memory column store inside of Tabular. Not a lot of adoption of direct query was in the real world because of the performance problem. There was the translation of the MDX from cubes and DAX to T-SQL, which would generate multiple T-SQL queries for one DAX or MDX statement. Now, SQL Server 2016 Analysis Services eliminates a lot of these problems. Also, the security roles can now be supported with direct query. There's also full support for all DAX functions with Oracle and Teradata. Another big deal is the integrated workspace mode. I don't even know if this was asked for by the community, but it definitely helps in development. No longer do you need a tabular instance to develop. You heard that right. You do not need a tabular instance to create a project in SQL Server Data Tools. When you create the project, just select the integration mode instead of connecting to a tabular instance of SQL Server Analysis Services 2016. Another one that's been enhanced is the Configuration Manager. Now, because of SQL Server Data Tools supporting multiple versions, which was not in previous versions of SQL Server Data Tools, the deployment area has information where you can put the deployment for dev versus QA versus production all in one project or solution and select it during the deployment. And lastly, one of the most beautiful things is the Tabular Model Explorer. Just like display folders, this is something in the development part which helps separate the model.bim file into its actual objects in folders in the Solution Explorer. And many people are excited about this enhancement. We'll look at a demonstration of some of these new development features for SQL Server 2016 Analysis Services. First, we'll launch SQL Server Data Tools, which is in our Visual Studio 2015 shell, and we'll create a new project. We'll create a Tabular Analysis Services, and we'll just give it a name. Now, because we're creating a tabular model, it's going to prompt us to select an Analysis Services instance to use while authoring the projects. In the previous demonstrations, you saw us connect to an Analysis Services instance called ./SQL16. But what we can do now is select Integrated Workspace, and we no longer need a tabular model. Now, we can only use the 1200 and SQL Server 2017 instance types in order to use this, but it is available because of the new data tools. So if I create this on an integrated workspace, I created, remember, a project called IT, or IT. If I go to SQL Server Management Studio and connect to the Analysis Services instance, what you used to see is connect Analysis Services. We'll pick that instance, and then you would see a database name similar to the project. Like the previous demo had one called LNO SSAS. But what you don't see here is the IT one. Now what I'm going to do is go to my Task Manager, and I'm going to bring that over to the display and sort by name. And what you'll see in here is actually some Analysis Services instances now running. Now I only have two of them actually running, and it's these two right here, but now you see a third being launched. Because of the integrated workspace, it launches one in the background and does all the work and then closes it down for you. This is really cool because now you don't have to install a local one, or do you have to connect to a remote one somewhere inside your domain to actually do the development. Now we're going to go back to the SQL Server Data Tools, and we're going to open up the previous project we created. And what I want to show over here is our, well, that's the wrong one. Let me open up the right one. Oh, it's not displaying. Oh, there it is. Here we go. So what I wanted to show is this Tabular Explorer Model Explorer. You'll see it's a new tab next to Solution Explorer. And so instead of everything being in your model BIM file and then having to display it in your tabs, you now can look at it by an Explorer. So here is my connection for my data source, my measures, and if I click on one, it jumps to it in the tab. So if I go down here to relationships and double click one of these relationships, it pops up. I no longer have to go down to the grid and then go find the relationship and then double click it. I can just do it from this particular folder here. Same thing with tables. If I want to go straight to the column fiscal year, what it did was it looked at it inside of the grid, the diagram mode. But if I want it inside the grid, I double click it and it goes to that particular column. That is real neat, and people have been looking forward to this for a long time. I'm going to close that and go to our Solution Explorer. I'm going to right click on Model BIM and I'm going to say View Code. What you'll see now is that instead of the model.bim file being an XML structure, it is now a JSON structure. Not only does it save space, but it also makes it hugely readable than previous versions of SQL Server. Now, since this model was built in a 1200, it shows it in the BIM. But if we go create a new one, and we call this one IT 2014, when it prompts us for the compatibility mode, and we pick 2014 and OK, if we go right click the model and view code, it actually shows it as XML. So it's only in the compatibility above. Now, one thing to take note before we close out this demonstration is that once you upgrade or create in an older compatibility, you can no longer, because of that JSON structure, go back to the previous compatibility.